Logarithm. I know many of the students are afraid of this chapter logarithm. I'm doing a simple experiment over here to explain you in a better way. Let me try. We generally measure the things with a certain scale which are linears in the nature. That is, we majorly measure with the scale which has written 1 with the unit distance 2, then 3, then 4, then 5, then 6. The distance between them is a unit distance, right? Now the measure is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have generally seen our scale in our life with these measurements. Now, if you have to measure a very big quantity with this scale, it's difficult for me to measure it. Or if I have to compare a very big quantity, say 10 raised to power 5 or 10,000 with the 1, so I require a very big scale to measure it. Suppose if these numbers which are done to the exponents, suppose that there is these numbers, let's say 1, 2, and 2 into 2, 4, 4 to the 8, 16, 32. If I write this number at the equidistance, then these numbers are in the exponent form, or they are exponentially increasing, right? The exponential factor or the base, which termed here is a base here is 2. So this is a 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. If I scale with this number kind of numbers which are increasing exponentially, here I can measure the big quantities. So 1 indirectly I can say 2 raised to power 0, this is 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, and 2 raised to power 5, and so on. And suppose if I require a very big scale also, so I just change this base. This is here the base was 2. Let me change the base with the 10. 10 raised to power 0. The next number will 10 raised to power 1, 10 raised to power 2, 10 raised to power 3, and so on. That means the base changed from 1, 10, 100, 1000, and 10,000, and so on. So I say at the 4 unit distance, after the 4 unit distance, I get the value 10,000, right? So if I have to measure the quantity, suppose quantity 3,433, 3,433, therefore this 3,433 lies somewhere between here 1000 and 10,000. So this is the way to measure, to mark out of the bigger quantity with the smaller quantity onto a same scale. We require this kind of things. So the more the bigger number we require, we increase the base. Here the base was 2, numbers were 1, 2, 4, 8, 16. Here the base is 10, number of 1, 10, 100, 10,000. You can use the base 100. If we use the base 100, then the numbers would be a very big one. So this kind of a things, now these things are increasing the exponential way. These all are the exponential things. And to handle this kind of a things, we require the logarithm, right? Or in other words, let me say the basic definition of logarithm is, we represent logarithm like this: log a n, which is equal to x. This means this is equivalent to a raised to power x equal to n, right? The logarithm of a number n to the base a is the exponent indicating the power to which the base a is to the base a must be raised to obtain the number n, right? This number is designated as log a n equal to x. Now, anything that is power to x, a raised to power x, we are getting n. In the logarithmic way, we write in this way. We are not aware about the power, we write in this way. So, if I look again at the scale, this is again written into the logarithm. So, I can say 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8. Now, if I say this is logarithm scale, so this 1, 2, 3, 4, 5 is nothing more than that. It's like 2 raised to power 0 is 1. I'd say log 1 to the base 2. 1 base here is 2, 2, 2. 1 to the base 2 is 0, right? Log 2 to the base 2 is 1. Log 2, 4 to the base 2 is 2. 0, 1, 2, 3. Now again, if I write this 8 to the base 2, I get 3. 16 to the base 2, I get 4. 32 to the base 2 is I get 5. So in this way, the logarithm comes into the picture. More precisely and more effectively, let me explain you again the logarithm here. Here let's say a raised to power x is n, and completing the definition, a should be greater than 0, a should not be equal to 1, and n is greater than 0. I know this is not easy to digest this kind of a thing. A greater than 0, a not equal to 1, and n is greater than 0. Let me give an example over here. A raised to power x is n. Let me say a be a 2 number, 2, n equal to n. A raised to power x, x is a variable, and here is the n. Say if I say 2 raised to power 0, I'll get the value 1. 2 raised to power 1, I'll get the value 2. 2 raised to power 3, I get the value 8. 2 raised to power 2, I get the value 4. 2 raised to power 3, I get the value 8. Right? Now, the factor we are understanding is I'm increasing the value 0, 1, 2, 3. That is the integer form. I'm getting the value here 1, 2, 4, 8. What about the value here is 1, 2. Then might we have 3, 4. There might be a 5, 6. So the value 3 here is 2 raised to power x. This x is, must be between 1 and 2. Right? This x must be between 1 and 2. 5 and 6 something between 2 and 3. The value of 5 and 6 is between 2 and 3. So the variable part here is x. So I need to equate the x with something. This a raised to power x equal to n is an equation. This is the power x. If I have to rewrite this equation, I have to use the word logarithm. X is equal to log a to the base a and the number is n. This number n. So in this way I can write. Now logarithm of writing this is 2 raised to power 0 is 1. That means log 1 to the base 2 is 0. 2 raised to power 1 is 2. Way of write is this 2 the base is 2 is 1. Right? 2 raised to power 3 is 8. I can say log 8 to the base 2 is 3. Now this is the quantity. This quantity is called the base. Right? In logarithm and the scale also. This is the result and this is the variable x 0, 1, 2, 3. Right? This is the way to write logarithm. Now coming to the picture and let's talk more about the base. Let's more talk about the base. We said that a should not be equal to 1 in a is greater. Why we said that? Because when a is greater than 1, that means a raised to power x is 1. A is 1 raised to power x is n. X can be any value. We will not determine the x. X can be any value. We will get the value as 1 itself. So we generally says a should not be equal to 1 because we are not getting any value of the x over here. And similarly we will not say that the a should be negative. A should be positive and not equal to. In general, whenever we write the logarithm, in generally we use the logarithm scale or we use the base in the logarithm as 10. Whenever there is nothing written in the question, we assume the base as 10. This is called the common logarithm. Common logarithm in which generally the base is 10. Suppose if I ask you log 100, obviously here is the base is 10 and 10 raised to power 2 is 100. Log 100. So if I ask you what is value of log 100, nothing is given here. By default the base is 10. Now 10, 100, answer here is something value 10 raised to power x to get the value 100 is what? X is 2. So here the answer is 2. And there is one more base which is called the natural logarithm. Natural logarithm. The base here is called e. The value here of e is irrational value which is between 2 and 3. Approximate value of e is 2.7182. Right? And the way we write log any number say 3 to the base e can be written as ln 3. If the word ln is used, it means the base is e here. Right? This is the natural logarithm. If we said that log 10 to the base 1 is 0 because 10 raised to power 0 is 1. Log 2 to the base 10. 10 raised to power something which gives value 2. Now this is a very new thing for you. Now, and so on, log 3 to the base 10, something 10 raised to power x which give you 3 value, and so on. If I say log 10 to the base 10, value here is 1 because 10 raised to power 1 is 10, and so on. Log 100 to the base 10 is what? 2 because 10 raised to power 2 is 100. 10 raised to power 2 is 100. Now, important thing learning over here is 1, 2, 3. Now the value here is 2, 3 is value between 0 and 1. That means log 2 and log 3 has certain value which is between 0 and 1. And then from 10 to 100, 10 that means 11, 12, 13, 14 up to 99, the value is between 1 and 2. So this is a very important thing. Value of log 11 to the base 10 or log 15 to the base 10, then 95 to the base 10 is the value between 1 and 2. Right? For practicing the things, you must remember the log 2 to the base 10 is Value here is 0.3010, or use the logarithm table. Log 3 to the base 10 is 0.4771. So remember these two quantities, get the other quantity.